Example 4 says a company uses the function r equals 12 log of a plus 1 plus 25 to relate sales revenue r in thousands of dollars and advertising costs a in thousands of dollars. Solve the equation for a. Which equation will be more useful to use if you know the revenue and want to find the advertising cost? So currently the equation says r equals everything else. When it says solve the equation for a, they want you to say a equals everything else. So we're going to use our techniques from yesterday to do this. And you'll notice this is a logarithmic function. So currently this is my logarithmic statement, log of a plus 1. Notice no base is listed, which means it's base what?
10.
Base 10. All right. So my first task, my first goal is I need to get that log statement by itself. If I wanted to say a equals, and currently a lives inside the logarithm, to get the logarithm out of the problem, I need to get the log isolated to change it into an exponential function. So I'm going to get r equals 12 log of a plus 1 plus 25. So issue 1 is the plus 25 needs to come over to this side. And then issue number 2, division by 12 to get rid of the 12. Always deal with a plus minus issue first and a multiplication division issue second. So if I chop the plus 25, it comes over here negative 25. So r minus 25 is the best I can do there. And then over here I still have 12 log of a plus 1. Okay, so now, again, my overall goal, I want log all by itself. The 25 is gone, it's not into this. My next task, I need the 12 to go away, so I'm going to divide by 12 here, divide by 12 here. And that gets me r minus 25 over 12 equals log of a plus 1. Now I do want to transform this into an exponential function, so if I'm going to do that transformation, personally I like to see the 10 there. I like my eyes to see what I'm going to be using. So it is an understood base 10, but at this point I want to have a 10 in my problem, so putting it in there is helpful to remind me that there's a number there. And the rule states to go from logarithmic to exponential form, we take the base 10 to the power over here equals the argument. So I'm going to end up with a plus 1 equals 10 to the r minus 25 over 12 power. Now the logarithm's out of the problem. My task again is to get it to say a equals. By getting a out of the logarithmic argument, now I have the ability to move the 1 to the other side. Just do basic algebra, chop the 1, make it negative. So altogether a is going to equal 10 to the r minus 25 over 12 minus 1. Now, when we look at these two functions that we have now, we have function 1 is what they gave us, which is up here. That tells me the revenue if I know the advertising cost. And if I know the advertising cost, to evaluate the revenue, I simply have to replace a right here, then type that expression in my calculator, hit equals, and it's going to spit out the answer. If I have this function down here, if I know the revenue, and I substitute it into this expression, I can figure out the advertising cost. So it says, which equation would be more useful to use if you know the revenue and want to find the advertising cost? So if I know the revenue, I know R. If I know R, it's easier to go there. It's already solved for A, just replace R right there. So let's just imagine this company has a revenue of $75,000, let's say. If the revenue is $75,000, what would R equal? So let's look and see what R represents. R is the sales revenue R in thousands of dollars. So if we made $75,000, what does R equal? Say again? If the revenue is $75,000, what would R equal?
75.
75, right? The R is the revenue in thousands of dollars. So whatever R is, you stick 1,000 after it. That's what. So 75 is R. That means $75,000 is revenue. We're gonna find A in thousands of dollars, so if A ends up equaling 4, then it's 4,000. If A is 2, it's 2,000. If A is 5.5, it's 5,500, right? So each of these is in thousands of dollars. So if you know the revenue is 75,000, R is gonna be 75. We put 75 right there. Grab a calculator.
How do you know it's 75?
I'm just making up a number.
Oh.
So I've supposed the revenue is 75,000. I'm just making up something here. So we're supposing the revenue is $75,000. I just invented that. Didn't come from anywhere. I could have said any number. I just said 75. That means R in our formula is going to equal 75. And if I come over here and let R equal 75, I'm going to say 10 caret parentheses, and then I want to subtract 75 minus 25 on top, so parentheses again, 75 minus 25 in parentheses divided by 12 in parentheses minus 1. It would be, well, that's a lot of money. I don't think these are good equations. Oh well. We did it correctly, I think. So 14,676 times 1,000 would be $14,676,993. If I'm running this company and I'm making this much money and spending that much in advertising, I'm probably not a very good business person. But again, that's the idea of this function, though. That's how it works.
You just make up your own number?
I just made up my own number for this. Again, if you're doing this problem in the book, they're going to say this is what it is. They didn't ask me to do that. I'm just showing you how we use the function. The other option would have been if R is 50 right here, we'd have to go through all this work to figure out what A equaled. Whereas here, we've already figured it out, a formula for it, so we can just substitute it in. So that's how that works.